Hello and welcome back to 30 days of AWS Terraform. This is day 10 and in this video we'll be looking into Terraform expressions. Yes, we'll be doing demo, we'll be understanding the concept in detail, in depth, and then make sure you complete the task given in the GitHub repository of day 10 folder and make sure you do the submission for 30 days of AWS Terraform challenge. If you are new here, hello, my name is Piyush and Cloud and DevOps is what I do all day long. In this series, make sure you watch day 0 video because it has many important details, many important information that will be helpful for learning AWS Terraform as well as for completing this challenge, which is like a marathon that we are doing together as a group, as a community, and there'll be prizes at the end as well. All the details will be given in day 0 video. So make sure you watch that and let's get to the video now. As I've mentioned in this video, we'll be looking into Terraform expressions. So what are these? Terraform expressions are something that helps us avoiding to rewrite the code again and again. You must be wondering, so what is the use of function then? Consider this as a replacement of functions because functions we have not covered yet and we'll be looking into Terraform functions as well. But these are similar to functions as in you can just reuse your code or you can actually create meaningful insights from the code without actually writing the function. So there are different type of Terraform expressions that you have, which is conditional expression, dynamic block, and splat expression. Again, these are not the functions. These are some helpful syntax given by Terraforms. As the name suggests, these are the expressions. So in conditional expression and splat expression, these are just the one-liner things. Conditional expression, consider this as true or false. Like in any programming language, you have true or false, right? So this is a conditional expression, which either is true based on a condition or false. Then we have dynamic blocks. Dynamic blocks help us write the nested block with multiple values, and it may sound confusing at this point, but when we'll do the demo, everything will be clear, I promise. Then we have splat expression. Splat expression is again a one-liner which help us to retrieve multiple values within just single line and using this star operator. Okay, so let's start with the first one, which is conditional expression. So conditional expression is something that has a condition. Okay, condition could be let's say your instance name or your environment name, and then there is an operator which is question mark and then true value. That means, let's say if environment equal to dev, then choose this instance type, else this colon represents the false value and choose this instance type. Okay, so let's say we are saying var dot environment equal to if it is dev, then question mark, use if it's a dev environment, then use var dot instance type is equal to t2 micro for dev environment, else if it's not a dev environment, then colon var dot instance type is equal to, let's say, t3 micro or something else. Okay, so this is just an example and we'll be looking into this example now in our VS Code with the help of a working demo. Okay, so let's go to our VS Code and I'm in day 9 folder. So let's go one directory back and create a new folder for day 10. So I'm just gonna copy day 9 and create day 10 folder. Okay, so day 10 folder has been created. Now I don't need the main.tf and old.tf. So let's remove these files and let's remove this file. Oh, did I not in day 9, actually in day 10. Okay, let's delete this as well. Okay, now let's go inside day 10 folder. Okay, now let's set the alias first. tf equal to Terraform. This is something that we have covered multiple times, so I'm not explaining it. That's why we are in day 10 and I'm pretty sure you are following this series in the same sequence, like from day 1 onwards, and you might have gone through day 0 as well. So that's my understanding. If that is not what you are doing, please make sure to follow in the same sequence. Okay, so Okay, I've set the alias now. Now let's run Terraform init to initialize the folder, initialize the repo. I've just created this folder and I've initialized it. Now I'm gonna create a new file inside day10 and call it main.tf. Okay, the first section that we need, or the first expression that we want to test, is conditional expression. Okay, so let's create a resource type. So I'm gonna go and search for AWS Terraform provider documentation, and let's go to the docs. Okay, this is provider documentation. Search for AWS instance, and let's go ahead. AWS instance over here. Okay, I'm going to copy any sample configuration from here. So let's select the simplest one, which is, let's say, this one. Oh, data source we have not covered, so I'm not gonna complicate things for you. So let's just copy from here and let's go back. Okay, I have pasted it over here. Now you can change the AMI name as well. I have shown you previously as well how to check the AMI name. So let's search for AWS AMI for Linux, Amazon Linux 2, Amazon Linux 2023, and go over here. Oh, not this one. Amazon Linux AMI, and scroll down, and here are the Linux images for the particular region. So I'm in US East Virginia, which is US East 1. So let's copy this AMI name from here, and I can just replace this one. Okay, now I have selected instance type as T3 micro for default. So let's just run this to make sure this does not throw any errors. So tf plan, and if it doesn't show any error, then we'll move ahead with making our changes. Okay, one plan to add, so no error reported. We are going great till now. So let's go ahead and let's replace the tags with var.tags. If you have followed the previous videos, there is a configuration in variables.tf, and if you check, there was a tags variable over here. Let's see where it is. Okay, over here it's a map of string. Okay, it has multiple tags with the default values. So this is what I have used over here to simplify the things. Now instance type is T3 micro. Let's add another meta argument, which is count. This is what we have covered. So let's say we are setting a variable count as var.instance count. Instant count should be there in variables.tf. If not, you can add that. So let's see if it's there already. Instance count. Okay, it's over here. Type is number, but there is no default value. So let's see if there is default value in tf vars. Okay, here it is. So let's update the count to 2. Okay, and let's change the environment variable to dev. Now let's go back in main.tf. Now we'll be creating multiple instances with this AMI and instance type, and the name we have not given the name, so we'll add few details. But before that, we need to change this instance type. Now we want this instance type to be selected based on the environment type. Okay, so how are we gonna do that? So we're gonna do that with the help of conditional expressions. Okay, so instead of this, or let's just comment this line. Okay, and I'm going to write it again. Instance type is equal to var.environment, okay, equal to dev. So what we are saying is set the instance type when var.environment equal to dev, then set the instance type to, let's say, T2 micro. Else, for else condition, we have to provide colon T3 micro. Okay, so this is the conditional expression that we are setting over here. Okay, so what does it say? Let's understand this one more time. I want you to be clear enough, so that's why I'm explaining it again. Instead of just hard coding the value over here, instance type equal to T3 micro, we are setting the instance type based on the environment, right? If it's a dev environment, we need smaller instance. If it's any other environment, let's say a higher environment, non-dev environment, then we are setting T3 micro, which is a bigger instance type, instead of hard coding it like this. And how are we doing that? We are just setting the instance type is equal to var.environment equal to dev, then T2 micro, and if it's not, then T3 micro. If we want to look at this example again, so this is what we are doing. I'm sure it should be visible. Okay, let's increase this a bit. So what we are doing is, instance type is equal to var.environment is equal to dev, okay, and then question mark T2 micro else T3 micro. Okay, so consider this. Let me just write it like this. Consider this as the condition. I mean, not consider, this is the condition actually, which says var dot environment equal to dev. That means this will be evaluated first. Okay, this section will be evaluated first, and then it will check the true value. This is the true value, which is T2 micro, and this is the false value, which is T3 micro. If this condition is true, then set instance type equal to T2 micro. Okay, like this. And this will be set if this condition is true, which is true in this case. We have the value dev. If this condition is not true, then set instance type as T3 micro. So we'll test these things. Okay, so let's go back over here. And now if you remember, we have the value in the variables.tf. We have where it is. Sorry, terraform.tfrs, we have environment equal to dev. Okay, so let's go ahead and run tfplan now again. So based on this, T2 micro should be set for the instance type. Okay, so let's check it out. So these are all the tags. Okay, and we are creating two instances because of the instance count that we have used. Now let's check the instance type. Okay, instance type is T2 micro for one instance, and instance type is T2 micro for the other instance as well. Let's see what will happen if we change the value of environment from dev to, let's say, anything, staging or prod or whatever, anything other than dev. Okay, let's run tfplan again. Okay, so in fact, instead of just going through everything, let's add a grep over here to find the value. So grep instance type. So we'll just grep that line. Okay, so you see now instance type has changed from T2 micro to T3 micro based on the value of environment variable environment. Okay, so this is how a conditional expression works. Okay, so now that's the conditional expression. Now let's move ahead with dynamic block. Okay, so for that, I'm gonna make some changes to variables, and I'll show you what I'm doing now. So let me just copy this. So I'm gonna create a new variable over here in variables.tf. Okay, and here is the value of that variable. So the variable name is ingress rules. So we'll be creating a security group rule. Okay, the variable name is ingress rule. Now this variable is a list of object. Okay, so that means first it's an object. Okay, so there is one object with multiple values. So there is from port, to port, protocol, CIDR block, CIDR block again is a list of string, because we are using nested data types. I'm sure it has been cleared now that we have covered data types earlier, or type constraint, whatever you want to call it. So what we are doing is we are creating a list of objects. Object, as you know, is a type constraint that has multiple data types contained within it, and that data type could have again multiple data types. For example, in this example over here, so there is a list of object. Okay, list of object as in, so if I just write it down over here, so we have a list of object, right? So that means there is a variable called ingress rules. Okay, this is what, this is a list, but it's a list of objects. So that means it will have the values of object 1 comma object 2 and so on, because it's a list, right? But it's a list of object. That means this object again will have multiple key value pairs of different data types. So this is what it is. Okay, so the way it works is this object has multiple types, and this is how we are defining it. So first is from port, which is of type number. Second is to port, which is of type number. Then protocol string. CIDR block, which is a list of string, meaning it could have multiple CIDR blocks with for this key, right? And then description again string. Now while adding the default value as well, we have to provide the same order, right? So the first should be from port, and the value should be a number, because this is what we have specified over here. Second should be to port, because this is to port is the next one, and the value should be number again, the same way, right? So we have a default value, this is 1, and then comma, this is 2. Why? Because it's a list, it could have multiple values. So the first value of that object is this, the second value of that object is this. We could have more values if we want, right? And let me just close it as well. So now what we need to do is, why we are using this, so we are creating a security group rule. Okay, so let's copy the definition of security group rule from the documentation. So let's from here, let's search for security group. Okay, so let's search for AWS security group. Security group, and not this one, we need the other resource which has ingress and egress. Okay, so like this, right? So it has an egress, and similarly it can have ingress as well. Okay, like this. So this is what we need. So let's copy this value from here and paste it over here. Now the resource is AWS security group. Let's call it ingress rule, or whatever you want to call it. VPC ID, you can use the default VPC. For that, if we remove this, I'm not sure if it's gonna throw the error, but it should take the default VPC. If we remove this value, let's double check this from here, from the documentation. So go to the argument section over here, argument reference, and search for VPC. VPC ID is optional. Right? Default to regions, default VPC. So if we omit this value, it will take the default VPC. Now ingress will have from port, to port, protocol, and CIDR block. Many of these values are optionals, but we already have it. So these three are mandatory: from port, to port, protocol, and CIDR block. Okay, so let's put it over here. Inside ingress, we have from port. Okay, so let's put it 80, then to port, let's put it 80, then CIDR, what's the name of the, let's see, CIDR blocks. Okay, blocks, and we know it's of type list, so you can just put that inside square bracket 0.0.0.0/0. Okay, and protocols protocol is HTTP. Okay, I think there is some mistake. That's why it is showing this as red. What it's saying, expected a comma to the beginning of line. Okay, so we need to separate it with comma, I believe. No, still showing the error. Let's go back and okay, let's check where we have ingress. No, there is no oh, it has to be inside the curly braces, not the square braces. Okay, and now we can remove the commas. And what's the issue with this? Failed to recognize the value of this number literal, invalid number literal. Let's go back and CIDR blocks. Okay, it should be inside double quotes. Why? Because if you go over here, so this CIDR blocks, it's a list of string. It's a list of string, and a string has to be enclosed inside double quotes. So that's why. Okay, so now the errors are gone. Now let's say if we want to create two security group rules, one for HTTP and another for HTTPS, right? So how do we do that over here? We have to provide the values twice, right? So this will just create one security group rule. So let's just save this configuration and let's run tfplan. Okay, there is an error which says there is no closing braces for this block before the end of the file. Inside variable ingress 91, maybe inside variables. Let's see. It says this, and I'm missing braces. Okay, should be good. Let's go back and run tfplan again. Okay, now it says reference to a resource type must be followed by at least one attribute access specifying the resource name. It is throwing error on protocol equal to HTTP. Let's go back over here, and protocol is -1 for egress. -1 is, I guess, any, or like it will select the default port for that, for default protocol for that. Okay, so let's search the valid values of protocol. Okay, it says required protocol. If you select a protocol of -1, which is equivalent to all, which is not a valid value here, you must specify it from port to port equal to 0, supported value are blah blah blah. What are the other valid values of a protocol? Let's see. Yeah, it doesn't provide much detail over here. So if I search protocol, yeah, you can add, oh, this is IP protocol. And yeah, let's try to add maybe, yeah, this is also, I guess, a string. So it has to be enclosed in double quotes, right? So that's why it is throwing the error. So HTTP. Now let's select it again. Okay, now it says inappropriate value for attribute ingress set of object required. All right, now it is throwing a different error. What it is saying that there is inappropriate value of attribute ingress set of object required. If we go back to, okay, we are not using any variable till now. It is throwing the error on line 12. Says set of object required. So if we check it over here, yeah, I could have prepared everything in advance and directly shown you the demo, but that's not how we learn. And if you have been following me for quite some time, you will know that we troubleshoot everything live over here so that we know, like everyone knows, you know, and everyone who's watching the video know that where are we making the mistake and how do we actually debug it, how do we actually fix it. That's why the video could be longer, but the learning is guaranteed. Okay, so it says the object something something is not valid something. Okay, so let's see the format. Okay, So we have from port to port protocol, CIDR blocks, and it's enclosed within curly braces. It's part of the security group. But what is the issue with it? Why it is throwing the error? Let's go back and see from port to port, CIDR blocks and protocol. Now it says line 12, which is this ingress, and it says incorrect attribute value type. Okay, I think I know the issue, and it's a silly mistake that I have done, which is this equal to sign. It's not like ingress. When we are doing this, we are just setting this as a variable over here, right? It's not the correct way. So I'm just gonna remove this and let's run the plan again. So basically your documentation is the true source of truth. So make sure you follow along with the documentation. And that's why I have disabled the GitHub Copilot suggestion as well. We don't need that at this point. Okay. So now it says errors are gone. Now it says 3 plan to add. What it is doing, it is now setting the AWS security group rule with the configuration that we have provided. What if we want to add one more ingress rule? So how do we do that? We do that with the dynamic expression within this block without rewriting the configuration again, without rewriting the security group rule again. And there could be 10, 20, whatever, how many rules. We can do that just within these 5 lines. And let me show you how. Okay, so first, instead of ingress, it start with dynamic, and you just give this dynamic variable a name. So we are creating a dynamic variable. That means the value will be changed as per the iterated value. And let me show you how. So first you start with dynamic ingress, and inside the dynamic ingress, because now you have to iterate through multiple values, right? So you start with for each, and for each inside the which variable, the variable that is over here, ingress rules. It has multiple values, right? It has, this is the first value, this is the second value. So that means we have to iterate in this list of object for the multiple values. So var.ingress rules. So for each is equal to var.ingress rules. Now like everything inside this var.ingress should come inside the content block. Okay, so content, and then I'm just gonna put that inside this curly braces. Okay, so this is how it should be. Okay, let's do some indentation so that it will make more sense. Okay, so this is what we have done. Instead of an ingress object, what we have created a dynamic block over here, right? A dynamic block starts with dynamic keyword with a name. So this is just a name that we have provided, and we are iterating through values defined inside ingress. Now you see it is still hard coded over here. We don't need that. We need the values from the variables.tf. Okay, so from port 80 and then again from port 443. Now if you remember the type constant video where we have discussed about map, right? How do we get the values from map? Using each.key, each.value, right? So this is a key value pair. So what we can do over here, from port we can do ingress. Now you don't have to access from var.ingress values dot something something, right? Because everything is inside this ingress dynamic block now. So you can directly access the value from here. So ingress dot value dot from port. Okay, similarly ingress dot value dot to port, and CIDR block, which is ingress dot value dot CIDR blocks, and protocol again ingress dot value dot protocol. Okay, so now what it will do, if we do a dry run of it, first it will initialize the dynamic block with the name ingress. Now what will this ingress has? Ingress has the values of variable, which is ingress dot rule, and there is a counter for that. So that means if it has two elements, then the counter will go from 1 and 2. Okay, two times. So first time it will select the first element, which is this one. This is the first element. So based on that, it will go ahead and check ingress.value. Now ingress is over here. Ingress.value.from port, which is the value of the first element, which is 80, and then to port, protocol, and CIDR block, and so on, right? You can add the description as well. And once this is done, it will do the same for the second element, which is for HTTPS. And in that case, the value will be 443 TCP, and then the same CIDR block, and so on. So now if I run tfplan over here, let's see what it does. Now let's see the security group rule. So there is a CIDR block over here, which is for 80, and TCP. And then there is a security group, which is a new one, which is for 443, which is HTTPS. We only have one content block over here. And what it did, it iterated through multiple values from the variable files. Okay. So if you are still confused with it, make sure you do the practice. I will share everything in the GitHub repo. Make sure you complete the task given in the GitHub repo, and it will be clear than ever, right? Now, the third part, which is this one over here, and it's called Splat expression, right? So for that, let's do a small exercise for this as well. Okay, so let's do this. So we have created two instances over here, right? We have not created actually. I mean, we have planned it, but it's working. We have verified it with tfplan. Now, what if we want to create a list of a variable which has the list of all the instance IDs once it is generated? How do we do that? Okay. So for that, we can use the splat expression. Okay. So let's do create a local. Oh, we already have a local file. So inside local, oh, we don't have the local file. Okay. That's okay. You can do that within the same file, or you can create a separate file. I'm going to use the same file for now. So to get the list of all the instance type, let's create a locals. And inside locals, what we can do is let's create a variable called all instance ID. And from where we get the ID, we get the ID from var, okay, not var, AWS instance dot example, because this is the resource, right? AWS instance example and dot ID. Now, this is the interesting part. If you just do this, what will happen? Let's see. Like we are just actually setting the value, but we are not printing the value anywhere. So let's just use tfplan right now. Okay, let's see. Now it will throw the error. What it will throw the error? Because AWS instance type has count set, meaning it has two values. Its attribute must be accessed on specific instances. Like you have to provide the index, count.index. Like how are you accessing the values? So if I do ID 0, should it work? Let's see. Okay, inside the value does not have indices. Why? Because it's not a list. We can only provide this with the list. So how do we access this value? We access this value with, we can add for each and then count.index. That you can do. But what if we want to put all the values inside this variable? So for that, we can just do this example and over here star. Now what it will show, if I run tfplan, okay, now it does not throw any error, but let's see if the value will be printed. The value will not be printed over here. Why? Because it's not part of the resource, right? It's separate variable that we have created. So you can create an output variable. Let's create an output variable and call it instances, and inside that you can print, let's call it instances equal to locals dot all instance id count dot index. Oh, star. No, it won't work like this. Required value, an attribute name value is required here. Okay, so this is not how it works. Output variables, let's see how it works. I might have forgotten it. Oops, these videos does not have the output variable. Okay, so oh yeah, the syntax is like that: output and then value equal to this. Okay, where it is. Okay, so it should be value equal to this. Okay, so let's run it again. Let's run the TF plan again. It says a managed resource local all instance ID has not been declared in the root module. Local dot. Okay, maybe we cannot use. Okay, let's remove this. Okay, now how do we actually print this? Let's have a look at this. So if I do output and let's call it instances and then value is equal to locals dot all instance IDs. Let's see what it's gonna throw. Okay, so it says instances is a list with 2 elements, but the values will be known after apply, once you apply the changes, because if you remember, instance IDs will be generated after you apply the changes, after the instance will be created. Okay, so that's why it is showing known after apply, but this suggests that it is working. Now, how do we check this? How do we create the Splat expression? Okay, so you see, we go to AWS instances.example, okay, which is this resource over here. Okay, and now we need to get the value from it. This value could be ID, private IPs, it could be something else. And the way we get it with adding star in front of it, that means the count could be many. So it will check all the values, it will iterate through all the instances and get the ID from each of these instances. Right, so that's how Splat expression work. So you just use the operator before the actual field. Okay, you use operator star with the resource name, which is example in this case, and then you can use this value in some other variable, in output variables, and there could be multiple use cases. So that's how Splat expression work. So resource list star dot attribute. Attribute is like ID, private IP, name, or something else, tags, whatever fields that it has, all the arguments inside it. Okay. So yeah, so that's about Terraform expression. Make sure you go through the GitHub repository as well and understand this in detail. Make sure you do the practice, make sure you do the hands-on, and make sure you support the channel. Make sure you follow us on social media and keep sharing your progress with everyone. So that's it from this video. Thank you so much. I hope you had a great learning experience. Thanks for following along. Happy learning.